Hello, I am George Antonis from Cyprus, and I will present to you the term of the definite integral. Imagine that you are a police officer driving on your daily patrol. Usually, you drive at a normal steady speed. This is the graph illustrating the speed in relation to time. This area here equals the distance which was covered by the police car, so we can easily calculate the distance covered. But what happens when you're chasing a thief? Your speed keeps changing, so the graph looks more like this. How can we calculate an area under a curve? We begin to approximate the area by breaking it into n rectangles. Each of the rectangles has an equal width. In other words, we equally partition the interval between the two boundaries A and B. The height of the rectangles is the function evaluated at the left end point of each rectangle. Let's take AK as the area of the rectangle KLMN, where K is the point x K0. Then AK equals KL times LM. But we know that KL is delta x and LM is f of xk. So we conclude that AK equals f of xk times delta x. And as Lao Tzu, a great Chinese philosopher, said, "The journey of 1,000 miles begins with one step." Now we found the area of one rectangle. We will do the same for the rest, and in order to find the total area, we sum up all the areas of the rectangles. This can be written in a sigma notation, and it is called Riemann sum. For a better approximation of the actual area under the curve, we divide it in a very large number of rectangles when n approaches infinity. Then we take the limit of the Riemann sum as n approaches infinity. So the actual area under the curve is denoted by the integral as definite integral from a to b of f of x times dx. The dx is called differential, and it is found when delta x becomes infinitely small. This symbol here was given by Leibniz, and it is called the integral symbol. It's actually an expansion of the initial letter S of the word summa, which means sum. The two numbers a and b are called boundaries of the integral. Concluding, Bernhard Riemann has made a huge contribution to mathematics by giving the most accurate definition of the definite integral. Thank you for your attention.